Okay, so today we're going to be talking about 6.3. And 6.3 covers simplifying radical expressions. And so some of the objectives in this lesson that we're going to talk about, we're going to learn how to multiply and simplify radical expressions. Okay, and we're also going to learn how to divide and simplify radical expressions. Okay, well, you may be asking yourself, what's a radical? And a radical is just a fancy word for saying square root. It's the square root symbol. We've kind of already talked about some of this, how to deal with this symbol. And we know that if there is no number up here, that we assume that it is a 2. And that's just a fancy way for saying, a radical is just a fancy way for saying square root. So this is your radical sign. And this step of mathematics is going to help you in college algebra simplify whenever you have to use the quadratic formula. And so without going into that, it's going to help you be able to simplify that equation in your next class. And if you know these steps of how to simplify radicals, it's going to make it a lot easier for you in your next class in college algebra. So let's start with our first problem. Okay, we want to simplify the square root of 45. So we've talked about how to simplify perfect squares. Perfect squares are the ones where they come out even. So if I did the square root of 49, well, we know that the answer is 7 because 7 times 7 is 49. And we talked about how if you simplify the square root of 64, well, that's really 8. 64 is really 8 times 8, so the answer would be 8. Well, the problem with these is you really can't think of something that's going to multiply together that's the same, that's going to give you 45. So just like the process we talked about when we were doing least common multiples, you want to find the prime factors of 45. So you want to find the numbers that go into 45 that are prime. Remember that a prime number is a number that can only be divided by 1 in itself. So 2 is prime because only 1 and 2 goes into it. 3 is prime because only 1 and 3 goes into it. 4 is not prime though because 1 goes into it and 4 goes into it, but also 2 goes into it. So we want to find the prime factors of 45. If possible, I always start with 2. And I'm noticing that 45 is not an even number, so 2 is not going to work. So I'll go up to the next prime number, and that would be 3. And I think about, will 3 go into 45? Yes, it will, 15 times. Okay, I want to keep going until the bottom number is prime, and 15 is not prime because other things go into 15 besides 1 and 15. So I'm going to keep going with 3 until I can't use 3 anymore because 3 will go into 15 5 times. Now 5 is prime because only 1 and 5 goes into it. So I am done here. So what I have just figured out is 45 is really 3 times 3 times 5. Which I'm getting this from right here. This is the same way when we looked at least common multiple that we did this factor tree. Now, if you go back up here and look, we knew that 7 times 7 gave us 49. If we had a pair of sevens, then the answer was 7. If we have a pair of eights that multiply to be 64, then the answer is 8. Well, it's going to be the same thing here. We're looking for pairs of things. So I've got a pair of threes, which means that I can pull the 3 out front in front of the radical sign. And then I have this 5 left underneath, which is going to go underneath the radical sign. And this means 3 times the square root of 5. So the square root of 45 is equal to 3 times the square root of 5. This is the simplified form of that. Okay, and you can always check yourself with your calculator to see if you're on the right track. So if I go to my calculator and I type in the square root of 45, I'm just going to write down round to the tens place. It's approximately 6.7. And then if I type this in, you would do 3 square root of 5. And it also tells me that it's approximately 6.7. How are you? Good. Okay, so let's look at the next one. So I'm looking at the square root of 12. And so 12 is not a perfect square. So we're going to have to do our factor tree of all the prime numbers that go into 12. So I always start with 2, and this 12 is even. So I can use 2. If I can't use 2, I want to go to the next one, which would be 3, which would be my next prime number. And 2 will go into 12 6 times. 2 will go into 6 3 times. And I can stop here because 3 is prime. And so what we know from this is that the square root of 12 is equal to the square root of 2 times 2 times 3. Now, if we were doing the square root of 25, we would know the answer is 5 because 5 times 5 is equal to 25. So it's the same thing here. If you've got a pair of something, that's what you get to pull out, and that's the answer. So if we've got the square root of 12, I do have a pair of 2's. So that's what gets to go on the outside of that radical sign. And whatever is left that doesn't have a partner or a pair will go underneath the radical sign. So the square root of 3. Okay, and you can always check this on your calculator. So this square root of 12 is not simplified. 2 times the square root of 3 is simplified. So we could go to our calculator and make sure that we have the right thing by typing in the square root of 12. I'm just rounding this to one decimal place or the tenths place. It's going to be approximately 3.5. And if I type in 2 square root of 3, and that means 2 times the square root of 3, but your calculator is fine with just 2 square root of 3. It knows that's a multiplication. Well, that's going to give me approximately 3.52. So I know that I did it correctly because I'm getting the same thing. Okay. So the next one is the square root of 40. So 40 is not a perfect square. I can't think of 2 things that multiply together to give me 40. So I need to find the prime factors of 40. 40 is prime, so 2 will work. I like to always start there if I can. The next one would be 3. 2 will work again. 2 will go into 10 5 times, and I can be done here because 5 is prime. Only 5 and 1 go into 5. So what that tells me is that the square root of 40 is equal to the square root of 2 times 2 times 2 times 5. We can pull out anything that we have a pair of. So I've got a pair of 2's. So that means that 1, 2 gets to go in front of the radical sign. Whatever is left, the 2 and the 5, we would do 2 times 5, which is 10, and that's going to go underneath the radical sign. So the square root of 40 is equal to 2 times the square root of 10 when we simplify it. If I check this on the calculator, the square root of 40 is, I'm just rounding to 1 decimal place, approximately 3.2. And 2 times the square root of 10 is approximately 6.3. So I know that I'm on the right track. I've at least kept them equal. Even if I didn't simplify it perfectly, I can check that there. Okay, let's look at the square root of 18. So 18 is not a perfect square. I can't think of two numbers that will multiply together to get me 18. And so I'm going to say, okay, well, 2 goes into 18 9 times. Can't use 2 anymore because 2 does not go into 9, but 3 does. So 3 goes into 9 3 times, and then I can stop here because 3 is prime. So the square root of 18 is equal to the square root of, 2 times 3 times 3. I can pull out front anything I have a pair of, and I have a pair of 3's. So that gets to come out front, and then I've got the square root of 2 underneath. Okay, and once again, we could check this on the calculator to make sure the square root of 18 is the same as 3 square root of 2 as a check, okay? So what happens whenever I have a number in front, like this 3 times the square root of 8? Well, what I want to do is the 3 is fine out here. But what I need to do is make sure that the 8 can't be simplified. So I have to look at the prime factors of 8. I know that 2 goes into 8 4 times. I know that 2 goes into 4 2 times, and 2 is prime, so I'm done with that. So what I really have, I'm just bringing down the 3. And 8 is really 2 times 2 times 2. So I'm going to follow the same process. I'm going to bring this 3 down, and I've got a pair of 2's that I can pull out front. And then I've got this 2 that's left that would go underneath my radical sign. So that's going to be 3 times 2, which is 6 square root of 2. So these things are equal. 3 square root of 8 is equal to 6 square root of 2. This is not simplified. This is simplified. And if I type this in my calculator really quick, 3 square root of 8 is approximately 8.5 if I round to 1 decimal place. 6 times the square root of 2 is approximately 8.5. So they are at least the same thing. Okay. So another example, we've got negative 7 times the square root of 75. Okay, I'm going to bring the negative 7 down. There's nothing I can do with that, but I do need to evaluate 75. 2 won't go into 75. 3 will go into 75 25 times. And then 3 won't go into 25, so I'm going to go up to the next prime number, which is 5. We'll go into 25 5 times. 5 is prime, so I'm able to stop there. So the square root of 75 is 3 times 5 times 5. Bring my negative 7 down. Going to look for any pairs I can see, and I do see a pair of 5's. Okay, and so I can pull that one of the 5's out front, and then the 3 that doesn't have a pair is going to go underneath the radical sign. And so I'm going to say negative 7 times 5, which is going to get me negative 35 times the square root of 3. -7 square root of 75 is equal to -35 times the square root of 3 when we simplify. Questions? You good? Okay, awesome. So if I have the square root of 104, okay, and I have a student who worked the problem. So this is just I have a student who worked the problem like this. They're trying to reduce this square root of 104. So they knew they couldn't find a perfect square here. So they came over here and they said, okay, I need to do this. So they did 2 will go into 104 52 times. 2 will go into 52 26 times. And they said 104 is the square root of 2 times 26. And they got, oh, I have a pair of 2's here. So 2 square root of 26. And they even checked it in their calculator. And they said, okay, the square root of 104 is equal to 10.2. They said 2 times the square root of 26 is approximately 10.2. Did they work this problem correctly? Maybe the only thing that I can see that's really wrong about it is that this right here is they've not prime, right? But let's look and see. So if I kept going with this and I did 2 will go into 26 because they just didn't finish. 2 was not prime. 2 will go into 26 13 times, right? So still they on this part right here, they would have gotten 2 times 2 times 2 times 13. They would have pulled out the pair of 2's, but these two didn't have a pair and they would have ended up with 26. So this is an example where they got lucky, right? Because it was possible that there would have been more pairs because they didn't keep going. Okay. But they ended up being correct. But you did catch the mistake, so that's good. Okay. So let's add a little bit more. We're going to multiply these. So our first problem on multiplication is the square root of 12 times the square root of 8. Well, the first thing you're going to want to do is just multiply 12 times 8. Okay, and 12 times 8 ends up being the square root of 96. That's not a perfect square. So you're after this, you're going to work the problem exactly like you would work any of the rest of them. You're going to look at 96. You're going to say 2 will go into 96 48 times. 2 will go into 48 4 times. 2 will go into 24 12 times. 2 will go into 12 6 times. 2 will go into 6 3 times. 3 is prime, so I could stop. So the square root of 96 is really the square root of, looks like we have 5 2's. Okay, and we can pull out anything that has a pair. So I've got actually 2 pairs of 2. So I have 2 spaces for that out front. Can put 1 2 from that group, 1 2 from this group, and then this that's left, 2 times 3, would go underneath the radical. So the square root of 96 simplifies to 2 times 2, which is 4, square root of 6. So the first thing you're going to do when you see them and it's a multiplication problem, you go ahead and multiply the two numbers together, then you're going to simplify. So it's basically the same thing as we were doing before. We're just adding a little bit extra. Okay, so we've got the square root of 6 times the square root of 7. Well, we're going to do 6 times 7, which is going to be the square root of 42. Going to look at 42. 2 will go into 42 21 times. 2 will not go into 21, but 3 will 7 times. So that means that the square root of 42 is, and I stopped with 7. I should have said that because 7 is prime. 2 times 3 times 7. There are no pairs here. So I checked to see if there were any, but there are not. So the square root of 42 is simplified. There's nothing else I can do to that. There's nothing I can pull out of it. This one's similar. 5 times the square root of 13. Well, here's what I know about these two. 5 is prime and 13 is also prime. So I can go ahead and multiply 5 times 13 and get the square root of 65. But when I come over here and do 65, 2 won't go, 3 won't go, 5 will go 13 times, which I should have already known because 5 times 13, those are already prime. So I had already done that. And it's not going to simplify anymore because I don't have any pairs. So square root of 65 is it. There's nothing we can do. Okay. We have 2 more that look like this, square root of 84, and we also want to look at the square root of 125. So 84, 2 will definitely go into 84 42 times. 2 will go into 42 21 times. 21 is 3 times 7. So 2 times 2 times 3 times 7. We do have a pair of 2s that we could pull out front. And then the 3 and the 7 are going to stay underneath. So 2 square root of 7. 2 square root of 21 ends up being the square root of 84. That's the reduced version. So we would look at 125. 2 won't go, 3 won't go, 5 will go 25 times. 5 will go into 25 times again. And so we've got the square root of 125 is 5 times 5 times 5. We do have a pair of 5s we can pull out. And this 5 is left. It's going to go underneath the radical. So the square root of 125 is equal to 5 times the square root of 5. Okay. Okay, we're going to turn it up a notch. We have to add those crazy letters in here. So if I have, it says simplify the square root of x raised to the 11th power. Okay, x to the 11th power. Well, what do we know about x to the 11th? We know that it means that we have x multiplied by itself 11 times. Okay, and the other thing that we know that we have already discovered is if we were going to take the square root of 9, we know that 9 is 3 times 3. And so the answer is 3 because we could pull out a pair of 3s. So same process here. I'm going to circle the pairs that I have, which means I could pull out an x for this group. I can pull out an x for this group. Can pull out an x for this group. Can pull out an x for this group. I can pull out an x for this group. And I have this one left. So I have 1 underneath the radical sign left. So x times x times x times x times x, we have 5 of them. So that would be x to the 5th power times the square root of x. So when we reduce x to the 11th, it turns into this. That one was not too bad because there was only 11 of them to write out, but I sure don't want to have to do that every time. So is there a trick to this to be able to go just straight from here to here without having to write all that out? Because that's kind of a pain. So what you want to do is you want to think, well, I'm trying to divide these in groups of two. So you want to go, okay, well, how many times, what is 11 divided by 2? It's going to be 5 point something, right? 5 point something. So the 5 would be what you're putting right here for your x to the 5th. And then you're going to need to do, well, what is 2 times 5 is 10. So I don't have 10 of them. I have 11. So you'd want to subtract and do 11 minus 10, which would give us a remainder of 1. And that's where my x to the first power underneath, how many I have left is going to go underneath. If we're always pulling out, if we're just doing pairs and we're not cubing it or anything else, it should always be x to the first underneath. There should always just be 1 because we're dividing in groups of 2. So there should only be 1 left underneath every single time. So let's look at the next one because the next one says, what is y to the 37th? Well, I don't want to write out 37 y's. That would be a pain. So we could go, okay, well, how many groups of 2 is in 37? And 37 divided by 2 is 18.5, I think, right? So then we want to keep this number. This number would go on the outside with the y. We've got 18 pairs of y's. And then if you look at 37 times 2, how many y's did we use? I'm sorry, 18 times 2. We had 18 pairs of 2, so we would say 18 times 2, well, that's 36. But I had 37. So I would need to look at the difference, 37 minus 36, which is 1, which is what we said. There should always be just a y to the first underneath it. So the square root of y to the 37th would be y to the 18th times y, square root of y. Okay. So now we've got some numbers added in here as well. I'm going to look at my number first, 24. 24 is not prime, so we know that 2 goes into 24 12 times. And 2 goes into 12 6 times. And 2 goes into 6 3 times. So far, what I know about this is that we've got 2 times 2 times 2 times 3 from our factor tree. X times x would be x squared. Y to the third, this one's not hard to draw out. So y to the third would be y times y times y. So we want to see, well, what do we have pairs of? I've got a pair of 2's. I have a pair of x's, and I have a pair of y's. Those things that I have pairs of get to come on the outside of my radical. All the rest of the stuff the 2 and the 3 and the y that was left goes underneath the radical. So my final answer would be 2xy. 2 times 3 is 6, y underneath the radical. So same concept, even though we've added the letters. I actually think the letters are a little bit easier because you don't have to find prime factors of any of that. You can just list them out. So it kind of makes it a little bit easier. Okay, so let's look at the square root of 48, xy to the 4th. So we're going to look at the factors of 48. So 2 will go into 48 24 times. 2 will go into 24 12 times. 2 goes into 12 6 times, 2 goes into 6 3 times, 3 is prime, so we can stop there. And we've got x to the first power, and we've got 4 y's. It's y to the fourth. We are going to circle the things that we have pairs of. Those things get to be pulled out in front of the radical. And then underneath the radical is going to go the things that don't have a pair. So the 3 and the x would stay underneath the radical. 2 times y times y, 4y squared times the square root of 3x. Okay. So we've multiplied them. We have reduced them with numbers and letters. So the last thing that we need to do is we need to divide the radicals, and we're going to be done with 6.3. So let's look at a few more examples of dividing these radicals. This one's pretty, so these are a little bit easier. If I had the square root of 25 over 36, well, you can divide that into the square root of 25 divided by the square root of 36. The reason I want to do that is because those are perfect squares, right? The square root of 25 is 5 times 5, so the square root of 25 is just 5. It made it really easy. The square root of 36, well, is the square root of 6 times 6. So on the bottom, I would just have 6. And I'm done with that one. So we've got the square root of 3 over 64. Well, I know that the square root of 3 is not a perfect square, but I also know that 3 is prime. The square root of 64 is a perfect square because 8 times 8 is 64. So it might be smart to use that same method and see if I can get this reduced down. I would still have the square root of 3 on the top, but the bottom, 64 is 8 times 8. So that's I'll still have the square root of 3 up here, but on the bottom, that gets to just turn into an 8. It's perfectly fine to leave a square root on the top of a fraction, but you can't have it on the bottom. And we don't, so we're good there. The square root of 45 over 49. Well, I know that 45 is not going to be a perfect square, but 49 is, because 7 times 7 is 49. So I'm going to divide these up. Now I know the bottom is 7 times 7 is 49. So I'm going to end up with this, the square root of 49 is equal to 7. On the top, I'm going to have to do some work because I'm going to have to look at 45. 2 won't go, but 3 will 15 times. 3 will go again into 15 5 times. And so the square root of 45 is really 3 times 3 times 5. So I could pull out a pair of 3s, but I'd still have a 5 underneath that's left. And what you want to kind of do is see if you can reduce 3 over 7, but it does. 3 over 7 is already reduced. So that would be the final answer on that one. The square root of 40 over the square root of 64. Once again, I don't know what the square root of 40 is, but I do know the square root of 64 because 64 is 8 times 8. So that would be 8 if I divided that up. I'm going to go back, so I left out a middle step here. So I could say the square root of 40 over the square root of 64. And we do know that 64 is 8 times 8. So the bottom of that, the square root of 64 is just going to turn into 8. I'm going to have to look at 40. 2 will go into 40 20 times. 2 will go into 20 10 times. 2 will go into 10 5 times. And so 40 is 2 times 2 times 2 times 5. So we've got a pair of 2s that gets to get pulled out, but we're left with 2 times 5 underneath, which is 10. I am not done on this one because we can reduce this fraction. 2 over 8 is not reduced. And 2 can be divided by 2, and 8 can be divided by 2. So 2 divided by 2 ends up being 1. I still have this square root of 10. 8 divided by 2 is 4. So 2/8 is the same as 1/4. And most of the time, you're not going to see this 1 written in the front. It's like whenever we have a variable, we don't write 1 in front. We would just write the square root of 10 over 4 because it's just understood that's one of those. Okay. We are very close to being done. We've got 4 more problems that we need to look at because none of these had letters in them. So of course we've got to go back and add those variables. So the square root of 32 divided by the square root of 2. Neither one of those are perfect squares. So I know that 2 is prime, so there's really not a lot I can do with that. But I can look at 32. And 2 will go into 32 16 times. 2 will go into 16 8 times. 2 will go into 8 4 times. 2 will go into 4 2 times. So 32 ends up being the square root of 2 listed 5 times. So it looks to me like we have a pair of 2's here, a pair of 2's here. So those get to come out front. But I have one last 2 that's going to stay under the radical. So 4 square root of 2 over square root of 2. Is there going to be anything that I can do with that? Because the last step is you want to see, can this reduce? And what I'm noticing about this is when you have the exact same thing on the top and the bottom, then those can cancel out and we would just get an answer of 4. So that one absolutely could reduce. Square root of 50 over the square root of 2. 2 is prime, so I'm not going to be able to do anything with that. So I'm going to look at 50. 2 will go into 50 25 times. 5 will go into 25 5 times. So the square root of 50 would be the square root of 2 times 5 times 5. I could have a pair of 5s, so that gets to come out front. Have a square root of 2 underneath. Last step, don't forget to check and see if something will reduce, if your fraction will reduce or something will cancel out. Do we have anything here that's going to cancel out? Right, I've got a square root of 2 over square root of 2. So those are going to cancel out and we're just going to end up with 5. Okay, last 2 problems, we've got to divide the square root of 50 times x to the 6 over y to the 10th. Okay, we're going to divide that into the square root of 50 times x to the 6 over the square root of y to the 10th. Now, I'm noticing that both of these exponents are even, so they're all going to have a pair. 6 divided by 2 ends up being 3. 10 divided by 2 ends up being 5. So this should be an x to the 3rd and a y to the 5th. But I'm going to go ahead and stretch it out. Let's look at what 50 is real quick. So 2 goes into 50, 25 times, that's 5 times 5. If we stretch this top part out, we would have 2 times 5, and then we would have 6 x's. And we know the shortcut is to do 6 divided by 2 and get x to the third. I'm just trying to make sure I explain this. So on the bottom, we don't have any numbers to deal with, but we have 10 y's, and we know we can do 10 divided by 2 to get our answer. Okay. This is a y. So it looks to me like I have a pair of 5s and I have 3 pairs of x's. So that would be 5 x times x times x. For each one of these, I have a pair. I can, and this 2 is going to stay underneath. On the bottom, everything has a pair. So I would have 5 y's listed down here multiplied by each other. That's going to be 5x, since I have 3 of them, x to the third square root of 2. And on the bottom, I would have a y to the 5th. Y times y times y times y times y. Y to the 5th power. I'm going to look and see if anything will cancel out or reduce. I don't have anything the same on the top or the bottom. There's no number. This would be a 1 on the bottom, and 5 over 1 is not going to reduce. So there's nothing else I can do to that one. Here is our very last example. If I have the square root of 3x to the 9th over 25y to the 6th, we could write that as 3x to the 9th, the square root of 3x to the 9th over the square root of 25y to the 6th. Okay, I know that 3 is prime, so when I start listing this, I don't need to do a factor tree because there's nothing that's going to go into 3 except for 3 and 1. And I'm listing all these out just to make sure that I explain this. But remember that the shortcut is you're going to do 9 divided by 2, which is 4. So the answer should be x to the 4th, and we would have 1 left over to go underneath. Because 4 times 2 is 8, and the difference between 9 and 8 is 1. So we'd have an x that didn't have a partner down there. Okay, so we know that. On this one, we know that 25 is 5 times 5, and we would have 6 y's. Okay, and then if we wanted to cheat, we know that we would do 6 divided by 2, which goes perfectly. So we would have a y to the third. 6 divided by 2 is 3. We wouldn't have any remainders on the bottom. Now, so we took care of this already. We said x times x times x times x would be x to the 4th. And then we had 1x left over. But we also have this 3 that's left underneath that we didn't put. So that's got to stay under there. We took care of the y's to the third because we had 3 y's that have pairs. So y to the third would be on the bottom. And then we also have a 5 that had a pair. So it gets pulled out too. And we don't have anything under the square root because everything had a pair. The last step would just be make sure that everything cancels out. And if there is anything that's going to simplify it. And on this one, we don't have anything that's the same on the top and the bottom. So we're good. So I'm not going to cover 6.4 today because you really need to practice simplifying these radicals before we try to start adding and subtracting and multiplying them. So adding that part is pretty easy if you're really good at doing this part. So I really want you to practice doing 6.3 first, and then we'll add 6.4, 6.5, 6.6, because those lessons are pretty easy once you get this part down.